Class, let's talk about lab number 3. So you've already done lab number 2, and that was an experiment, not an experiment, but a correlational design. And so for lab 3, you're going to do a t-test. Let me share my screen. Okay, so I'm here on your Canvas homepage. I'm going to go over to modules, lab 3.1. Okay, so this lab is looking at the effect of category set on solution times for anagram puzzles. Zizi in 1959 found that an important factor in free recall of verbal materials is inner item associative strength. So within the list to be recalled, IIAS is a measure of interrelationships among units of a list. High IIAS exists if the units comprising a list tend to evoke each other frequently as associates, whereas a low IIAS is if the units in the list seldom elicit one another as associates. When items on the list are highly interassociated, it enhances free recall. The recall of given words tends to increase total recall by eliciting other related words in the list of high IIAS. So some other investigators saw a similarity between verbal recall situations and an anagram solution. Safran attempted to exhibit the similarity by showing that a category set exists in anagram solutions as well as in verbal recall. A category set may be viewed as readiness to respond to words belonging to a common class or a category, like a group of words with high inner item associative strength, IIAS. Thus, a list of anagrams whose solutions belong to a common category might be expected to be solved more readily than a list comprised of unrelated word solutions. That's a whole lot of stuff saying that if the words are similar, people are probably going to recall them better, and if they're not, they probably won't recall them as fast. So a list of anagrams whose solutions belong to a common category might be expected to be solved more readily than the unrelated word solutions. For example, all of the solutions to the anagrams in list 4 below are related to beverages, breakfast, food, and taste. If a category set comes into play during the course solving a list, the solution time for the anagram should be shorter than that for the control group, which receives a list of equal length, but all the words are not related. So that should decrease the solution time for successive anagrams when subjects solve anagrams made from associatively related words, since the associations called up by previously solved anagrams will aid the participant of the solution in the later problems in the list. That's amazing, right? Makes sense. And you're like, yeah, I could read that myself. But like I said, all of that research and all that data is just saying that if the words are related, if you have this inner item relationship between these words and you're asking people to solve anagrams, if there's a category or a set, that people will be able to recall it better and they should be able to solve the words quicker because their brain's kind of cueing them like, oh yeah, this is related to this, this is related to this, as opposed to just having completely random words that are nonsensical and have no relationship with each other. The participants in one of Safran's experiments received one of 6 different lists of 6 anagrams each. All the word solutions within any given list were highly interrelated. The control groups received 36 different lists of 6 anagrams, but the solutions in these were completely unrelated. The results supported the 2 main hypotheses: that the time for the solution would be shorter for anagrams from organized lists, where they belong to a common category, and the group with the organized list would show a greater decrease in solution time over the successive anagrams in the list. That makes sense. You're going to read that and be like, yep, that makes sense. But we're not just about what makes sense. We're science. We're a hard science. And so we're going to empirically collect this data. You're going to find 4 participants again, right? We're going to collect this data from them. I'm going to compile it all into a new CSV file, send out your data. You're going to compute it in JASP, and we're going to see if there actually is a difference, a significant difference with your p-value. So this study is a partial replication of Safran's experiment. Comparison of the solution times and improvement with a given list of 6 anagrams will be made between your 2 types of list, organized and unrelated. So you need 4 participants, hopefully other college students. They don't have to be psychology majors. If you can't find other college students, you can use family, friends of different ages, but ideally, we're trying to get a similar age range. They can be the 4 people that you used before, or they can be 4 random people, or they could be a couple people that you used before and new people. That's up to you. And if your volunteers are going to come back for more. 2 will be assigned to the organized list, and the other 2 will be assigned to the unrelated list condition. So once you have your 4 volunteers, decide which 2 are unrelated and which 2 are related. So for the materials, you're going to look at this table below that we're going to look at in a second. And you're going to, well, let's just talk through it and then I'll show you. So table 1 below contains a total of 36 anagrams. So this table right here, there's 36 anagrams. You can see list 1 is here, list 2 is here, 3, 4, 5, and 6. So in total, there's 36 anagrams, right? Here's the word, and here's it mixed up. Or, I mean, here's the word mixed up, and here's the actual word. The arrangements are such that the solutions to each list forms a common category. So list 1 solutions are words related to military. So look here at list 1. Let me zoom it up. As much as I can zoom it up. So this random word is command. This random word is order. This random word is army. This random word is obey. This random word is soldier. This random word is navy, right? So if you took this list right here, they would all be related and they would have something to do with the military. From these organized lists, 6 different lists of unrelated words could be obtained if you took one word from each of the 6 organized lists. For example, if instead of taking these 6 down in this organized list, you took this word, command, and whistle, and chair, and milk, and doctor, and square, and you gave that to your unorganized participant, those are completely mixed up. So if you're going to do the organized list, go down. You can either choose list 1, 2, 3, 4, 5, or 6. Or if you're doing the unorganized set, go across. So you can do row 1, row 2, row 3, row 4, row 5, or row 6 to get your unorganized list. Saffron did a lot more, but that'll be sufficient for ours. So you can either go down or across. After you choose your list, either one column and one row, prepare your stimuli by printing each anagram not solved. So write the mixed up version on one single index card. So you'll have 2 sets of 6 cards, 6 anagrams that are related and 6 anagrams that are unrelated. So you need 12 white index cards and a Sharpie, right? Or a thick black marker. And so for the related, you can pick whichever one you want, 1, 2, 3, 4, 5, or 6. And on your index card, you're going to write this word, right? Whichever list you chose, but write the mixed up version because they need to be able to solve it, right? And then on your other 6, your unrelated, whatever row you choose going across, write the mixed up word on one word on one index card each. So you'll have 6 index cards with one mixed up word each. You'll also need your data summary sheet, which I'll show you in a second. So after your participant is seated and comfortable in a quiet place, you're going to read these instructions exactly to each of your participants. This is an experiment on anagram solutions. As you may know, an anagram is a word with its letters rearranged. I will show you a number of anagrams one at a time. Your task is to determine without the aid of pencil and paper what the original word is. Work as quickly as you can since you will be given a maximum of 4 minutes for each anagram. As soon as you have a solution, tell me what it is. If you cannot solve the anagram in the allotted time, we will stop and we will go to the next one after I give you the answer. You will solve 6 different anagrams. Do you have any questions? Pause, and if they have questions, answer them, and if not, say, here is the first anagram. And so you'll hold it up to them, and they'll look at it, and they'll either solve it and tell you what the right word is, and then you'll say, here is the next anagram. And you'll do that 6 times, or they'll max out the 4 minutes, and you'll say the word is army. Here's the next anagram. And you'll start the 4-minute timer over again. So you're going to record the time in seconds for the solution of each anagram on the data sheet. You should use a stopwatch or your phone timer to record the solution time. If they don't solve it within 4 minutes, stop them, record 240 seconds. That's how many seconds are in 4 minutes. Give them the solution, and then give them the next anagram. These are Post-it notes, not a white index card. I didn't have any on my desk, but you have to use a white index card. As you go through the list, present the next anagram as soon as you have recorded the solution time for the preceding one. Do not discuss it the experiment, the words, the theme. Don't discuss anything until all 6 have been presented. And then before you do your next participant, make sure you shuffle the list of cards, right? We want it as random as possible. And then repeat the above thing that you just did. But make sure that 2 of them see cards from your related condition and 2 of your participants see it from your unrelated condition. Thank them for their time and their participation. And then you're going to scan and upload your data sheet. Round decimals up or down to whole numbers. For example, if your timer said 3.11 seconds, please record as 3 seconds. If your timer said 6.85 seconds, report as 7 seconds. I don't want to do math on everybody's fractions of seconds. So just give me whole seconds, please, round up or down. So let me show you what the data summary sheet looks like. Here, so you have participants 1 and 2. Can I zoom up? Here's Zoom. So you have your 2 organized list participants and your unrelated list participants. And so participant 1, their age, their gender, and then here's all 6 anagrams, right? How many seconds? 5 seconds, 10 seconds, 3 seconds, 7 seconds, 12 seconds, 14 seconds, whatever, because you're rounding up and down. And then your second one, and then your 2 unrelated participants. That's it. And then you're going to upload this paper only, and you're going to give it to me and upload it in lab 3.1 here. Assignments. Right here, and it's due February 23rd by 11:59 p.m. So you have enough time to make your index cards, to collect your data, and to conduct your experiment. And then once everyone's given me their data by February 23rd, I'll do the same thing I did with the last one. I will take it and turn it all into one big CSV file for y'all to analyze, and I'll post another video talking about analyzing it. So I hope that's helpful, and I hope you now understand how to conduct this lab. I hope everyone watches the video before you all email me questions about the related and unrelated word lists. But if you have any questions after you watch the video, definitely reach out to me.